Okay, so this one tells me determine whether each equation represents y as a function of x. So this means, can I get y by itself and be able to choose any x that I want? Okay, well, let's look at the first one. Well, so right now, x and y are on the same side, so let's get y by itself. So I subtract x squared, and that gives me y equals negative x squared plus 1. So now I have the y isolated. Am I allowed to choose any x I want to? Is there any restriction? Would there anything that would give me a problem if I chose the x value? No, there's not. I could pick anything to be x. So this means y is a function of x, because when I got y by itself, I was allowed to make x anything I wanted it to be. Now let's look at b part. B part says negative x plus y squared equals 1. Okay, let's see what happens when I get y by itself here. So I move the x over, it's going to become positive. So I get y squared equals 1 plus x. Now what do I have to do to get y by itself? Well, y is being squared. So to undo squaring something, I must take a square root. Anytime I choose to take a square root, I must always account for the positive or negative value of that square root. So when I'm choosing to take a square root, I always have to take plus or minus. Every time. You need to get in the habit of that. And then what's left underneath the radical is 1 plus x. Now, I've gotten y by itself. Can I choose anything to be x that I want to? What could I not choose? I couldn't choose, what if I chose like negative 4 for x? Then I'd be taking a square root of a negative. That wouldn't be so good. Let's also think about, what if I did pick something that was good? What if I chose x to be 3? Okay, so 1 plus 3 is 4. When I take the square root of 4, I get 2. So I plugged in a 3. Right? That was my input value. Now, what did I get out when I plugged in 3? Well, I got 2, but I had to account for 2 possibilities. So when I plugged in 3, I could have gotten positive 2, or it could be negative 2. This input value of 3 has 2 different possible outcomes. One could be positive 2, the other negative 2. This is not a function. So y is not a function of x here, because when I pick an x value, I could get different y values, which is not a function. Okay, so a part, when I get y by itself, what did we get? We got y squared equals negative x squared plus 8. And then I have to take a square root of both sides. Anytime I take a square root, I have to always account for the positive or negative possibility. So because I have this plus or minus, right? Anytime I choose an x and I simplify this, I'm always going to have a plus or minus that x, which means I plug in 1x and I'm going to get 2 y values out. So this would not be a function for a part because of the plus or minus. B part, y equals 4x squared plus 36. So I've got y by itself. Is this a function? Yes. It is. I've got y by itself. I can choose x to be anything. And whenever I plug in something for x, I'll always get the same value for y. So that is a function. Okay, a part tells me to find g of 2 given that g of x is equal to negative x squared plus 4x plus 1. So I'm going to take my g of x equation, and everywhere there used to be an x, I'm now plugging in a 2. So this is going to be negative 2 squared plus 4 times 2 plus 1. Okay, so right here, this is going to be the trickiest part of this one. So because I plugged in a 2 and the negative was already part of the problem, when I square this, I only square 2. I don't square this negative out front because it's essentially like there's a negative 1 there. It's negative 1 times 2 squared. So the negative does not become part of the square. So 2 squared is 4, and then the negative is going to make that negative 4. Plus 8 plus 1. So that's negative 4 plus 9, which should give me 5. So G of 2 is 5. Next tells me to evaluate G at T. So this is where people always start getting confused, and please don't. So what does G evaluated at T means? It means everywhere we used to have an X, we're now going to substitute a T. So this is going to be negative T squared plus 4 times T plus 1. And I'm finished. You confused? I'm getting some looks. I'm just telling you. Everybody's good with that? All right, and then C part. Oh no, those didn't stay together. Now I'm going to take the function G, and everywhere there used to be an X, I'm now going to substitute in X plus 2. So again, I have this negative that's already out here. Now I'm supposed to do X squared. So now that's going to become X plus 2 squared. And then I have plus 4 times X, which I'm now going to substitute in X plus 2 plus 1. All right, so order of operations. I have to simplify the exponent first. So I have X plus 2 that's being squared. So that's going to give me, I've got negative. So what does it mean when we square something that's in parentheses? We're multiplying it by itself. That's what squaring means. You can't just square X and square 2. You have to multiply them by each other. So we're going to have to distribute there. And then if you want to, you can go ahead and distribute here. 4 times X is 4X. 4 times 2 is 8 plus 1. Okay, so I'm just going to go ahead and distribute here. So X times X is X squared. X times 2 is 2X. 2 times X is 2X. 2 times 2 is 4. Okay, but I can't forget I had a negative 1 out front there. And now then I have the plus 4X plus 8 plus 1. So this is going to give negative X squared minus 4X, right? Because 2X and 2X is positive 4X. But then when I distribute the negative 1, that becomes negative 4X minus 4 plus 4X plus 8 plus 1. And now we're grouping like terms. So negative X squared, I have nothing like that. So it's negative X squared. Negative 4X plus 4X cancels. We've got 0. And then negative 4 plus 8 plus 1. That should give me 5. So G evaluated at X plus 2 should give me negative X squared plus 5. So normally I would make you work those out and call on somebody for the answers, but because we're almost out of time, I'll work them out for you here. So you can check your answer. We got about a minute left. If you have questions, come in and be ready to ask them about these first thing tomorrow.